Hi, this is Team Air Force One's, and our MAE 152 final project design was done on the Hyperloop. The Hyperloop is a high-speed transportation system that fits people within a tube, allowing them to move from point A to point B in a short amount of time. Our team decided to study the magnetic braking system of the Hypersight pod along with the guided rods and shaft collar, running FEE analysis on the parts in order to understand the static analysis of each part.
Here we have one of our structural members of our braking system. This is a static simulation. We see a 28 megapascal maximum stress. Our yield stress is 275 megapascals, which leaves us with a fairly high factor of safety. The load we applied to each of these cylindrical faces is 450 newtons. We see fixed geometry at these holes right here. This is where the plate is mounted to our structure. And this material is 6061 T6 aluminum. We used a circular based mesh to run this analysis.
So here we have the analysis of the support crossbar, which is a much bigger piece of our pod itself. The material is 661 T6 aluminum alloy. It's fixed along those top carrier holes over there that you see, and also it has a distributed load of 2575.12 newtons along the top, and 87 newtons along those bearings that you see down there. So the max stress that we see is around 36.3 megapascals, and the max displacement is around 0.0018 millimeters. And so next we have the support crossbar buckling analysis. So here that we see that due to buckling, the mode that you see here reaches the max value of that of the amperage area, and that is the analysis of support crossbar.
Hello, so here we have the AISI 316 annealed stainless steel guided rods. They have a boundary conditions of fixed along the sides where the guided rods are held in place with retaining clamps. Exacted on the center of the rod is a 450 Newton load that acts in the normal direction of the braking force. This yields a von Mises stress of 20.33 megapascals, which is below the yield strength of 137.9 megapascals, and it yields a deflection of 0.06 millimeters.
This is a static stress analysis of our structure shaft collar. It is used to support the shaft that runs through the entirety of the system on both ends. The material is 6061-T6 aluminum alloy. The boundary condition is that it's fixed along the outer shell of the collar. The load is a 500 Newton external load applied to the inner part of the collar, exaggerated for the purpose of this experiment to show the pressure that the shaft exerts on the inside of the collar. We see a maximum von Mises stress of 8.585 times 10 to the 6 Newton per meter squared, and a yield strength of 6.204 times 10 to the 8th.
The Hyperloop is the next big transportation innovation, joining cities together within minutes and changing the world. With SpaceX in charge of the competition, it will also bring engineers together, exchanging ideas that will benefit our society as a whole. Thank you for watching.